Today, our focus was the types of problems where we could draw a picture and solve them from that. But we did have one, I think like our renting a car example, where a picture didn't really make sense. Today we're looking at a different type of problem. We're going to talk about mixture problems. So I want to kind of ask a few scenarios first. Okay, let's say I am going to make some trail mix to sell for a fundraiser, okay? If I want to make a 10-pound batch of trail mix, and I want 50% of that batch to be M&Ms, how many pounds of M&Ms do I need?
10.
5 pounds. So, 100% would be 10 pounds of M&Ms. If I wanted 50%, we would need 5 pounds of M&Ms. What if I said I wanted 25% to be M&Ms? 2.5 pounds. What if I said I wanted 10% to be M&Ms? 1 pound. So how are you guys getting these? Math. Okay. So we started with our total amount. Okay, so we had 10 pounds total. When I wanted 50% to be M&Ms, you probably divided by 2, but isn't that same as multiplying by 0.5? And we got 5. When I said I wanted 25%, you probably divided by 4, but that's the same as taking it times 0.25. When I said I wanted 10%, we could take it times 0.1. So if we take our amount that we had to start with times the concentration, that's like our percent, it gave me the amount of M&Ms in this particular scenario. I'm going to call that, for the sake of a formula, the amount pure. Okay, I had 10 pounds of trail mix to start with. That was my total amount of the mixture. I wanted, let's say, 20% to be M&Ms. So I take 10 times 0.2, and I get 2 pounds of pure M&Ms. So we are going to look at mixture problems, and this is going to be the formula that we use every single time. So our amount of the mixture times the concentration of whatever we're looking at, and that would equal the amount of pure substance for whatever we're looking at. All right. Again, these problems are still on that examples handout posted on Classroom, so you don't have to try to write down the word problems as we go to them. We are in the same section, so you can just reference the handout on Google Classroom for those. So let's look at this one. Lots of chemistry scenarios come up into play here. How much pure alcohol should be added to 20 liters of a 40% alcohol to increase the concentration to 50%? I have a lot going on here, don't I? I'm talking about a 40%. I have a pure one. I'm trying to get a concentration of 50. It's a lot of information to keep track of. So my strategy, okay, there are other ways of doing it. So if you don't like this strategy, you're not committed to it, but it's going to help us on a lot of problems. When we have a lot of different information like this, I suggest drawing a table. So we are going to do across the top, my columns are going to be that formula that we decided on. So if we're working with concentrations, we can do the amount times the concentration concentration equals the amount of pure substance. In this case, we're looking for the amount of what? Alcohol in this particular scenario. My rows of this table are going to be the things that I'm mixing together. And I'm not real picky about these labels as long as you can figure out what they are. So you can call them as generic as you want. You could call it the first thing, the second thing, and the total. You can use the percents as your labels here. It doesn't really matter to me. We need some kind of label on that row. All right, so now we're going to start filling in the gaps. So we start out, how much pure alcohol? So the first thing I'm dealing with is the pure alcohol. And I started out with how much. So if we don't know, what do we put? X. So the amount of my first one is an X. The concentration, if it is pure, what is the concentration? 100%. We always have to put it in decimal form, so 100% is just 1. Should be added to 20 liters of 40% alcohol. So my second thing, the amount is 20 liters. Yep, so our amount is the liters in this case, concentration, that's our percent. Of the 40%, so we would do okay, to increase the concentration to 50%. So at the end, my total is 50%. So my final concentration is 0.5. All right, now we have to figure out how to fill in the rest. The amount of my total. If I put in 5 liters of the first one and 20 liters of the second one, how much do I have? 25. If I put in 10 of the first one and 20 of the second one, we have 30. How are we getting those? Add them. So if I put in X of the first and 20 of the second, then in the total, we have X plus 20. This column we can get from our formula. It's the amount times the concentration to get the amount pure. So we do X times 1, which is just a 1X. I do 20 times 0.4. And I have to do 0.5 times the X plus 20. If you can get this column, then you have practically solved the entire problem. What we're saying is, in the first thing I put in X liters of alcohol, of pure alcohol, and the second one I had 8, and my total was this. So what should my equation be? 8 plus X, yeah. So just like here, to get our total, we added the first and the second to equal the total. It's the same thing here. The amount from the first one plus the amount from the second one would equal our total amount. And now we just solve this equation. Subtract over my 0.5x, subtract my 8, divide, and we get 0.5. how do we have to answer? In a sentence. So the question was, how much pure alcohol? And if I look, X was the amount of my pure alcohol. Questions there? Let's try another one. How many liters of a 25% antifreeze solution should be added to 5 liters of a 10% solution to obtain a 15% solution? So anytime we're doing a mixture, I'm going to make a table to help organize my information. And my columns will be my formula. So the amount, so that's like the liters, times the concentration, which is like the percent, would equal the amount pure. Okay, my rows, you can be as generic as you want. You can call them first, second, and total. You could use the percents. What 2% am I mixing together?
10.
Yeah, we're mixing together the 25 and the 10, so you can call them those. I don't care how you label those, as long as you know what's what. Just a little hint. Sometimes people mix up the two you're mixing together. When you compare these percentages, it'll kind of, we could really know what our total percentage is without ever reading the problem. You're always going to mix the highest and lowest percentage and get something in the middle. So if I'm looking at these, the middle number is 15. So I have to be mixing together the 10 and the 25 to get a 15. If I look at my previous problem, we had pure, which is 100, we had a 40, and we had a 50. So the total had to be the 50. Your total will fall in between the other two percentages. Okay. Now we fill in our table. How many liters of a 25% solution? So if I don't know it, I call it the concentration of that one. Should be added to 5 liters of a 10% solution. So my amount the concentration to obtain a 15%. So if I want a 15, my total concentration here is 0.15, what would my amount be? So now we multiply. So x times 0.25 is 0.25x. 5 times 0.1 and 0.15 times the x plus 5. How do we write our formula? Exactly. It's always the amount of the first plus the amount of the second equals the amount of the total. Subtract over the 0.15. Subtract over the 0.5. So we get x equals 2.5. So the question was how many liters of a 25% solution, and that's what x represented. So there must be 2.5 liters of the 25% solution. Questions on that? I want you guys to try to set up one on your own. So we've got our table. And our formula is our amount, which is measured in liters on this one, but it could be gallons or something like that. It doesn't have to be liters. Times our concentration, which will always be your percent, equals the amount pure. What are we mixing together? What two things are we putting together? Okay, so I was asking for labels here. So if we don't know yet, let's just call it for a second total. We'll figure this out. What's the first thing it says? Okay, so do I know the amount of my first thing? So that's my x. Okay, concentration. We are mixing water. If I go get a drink out of the water fountain right now, what percent acid is that water? Hopefully zero, right? Water has nothing else in it, we hope. So the concentration, we're looking for the concentration of acid in this case. So water is what percent acid? 0. So pure is 100%, but water is 0. Should be added to 20 liters of an 18% solution. So my concentration is 0.18. To reduce the concentration to 15%. So my final concentration is 0.15. Quick check, does 0.15 fall between those other two? Yep, so we're on the right track. What would my total be here? So I'm going to multiply x times 0 is 0. 20 times 0.18.
3.6.
And we have 0.15 times x plus 20. This column is your equation. You add the first and second to equal your total. So 0 plus 3.6 equals 0.15 times x plus 20. So we subtract the 3. And we take it. Apparently 4 was my favorite answer when I was writing these problems. Seems to be a common answer on these today. Okay, so my question asked how much water, so there should be liters of water. Is that okay? We're probably going to do, let's look at another one. The next one I have is slightly different. A little more wordy here. Not quite as straightforward as the last couple. You have been tasked with creating an innovative dairy beverage. You have 30% heavy cream and 3.5% fat milk. Your target dairy product should have 7% fat. Since this is a test batch in your product development lab, you will be making an 8-pound batch. How much heavy cream will the batch require? I actually stole this from a food science contest team test.
That felt like a food science.
Yes, it's totally where I stole it from. But
With all the percentages.
And I recall Rose.
yes, I think that's when I got this question, when I was helping them with the math part. So Rose should be able to fill us in here.
Definitely.
So what should I do? Make a chart. That'll help us organize everything because there's a whole lot of information here. Okay, so my columns are my formula, my amount. What is my amount measured in this time?
Pound.
So my amount is my pounds this time.
Moving on kids.
Times the concentration, which is always a percent. And that should equal the amount here. Okay, without even really reading, let's just look at these percentages. Which two are you going to mix together? You have to mix the highest and lowest together.
3.5 and 23.
And your total would be the 7%. So you can use those percentages for your rows. You can call it first, second, and total. I don't care, whatever you like. So I'll say we have the 30%, the 3.5%, and our total. All right, so my 30%, the concentration would be 0.3. What's the concentration for the 3.5? The concentration? And my total was 7%, so the concentration would be all right. What's the only other thing given in our problem?
8-pound batch.
We'll be making an 8-pound batch. So is that the amount of the 30, the amount of 3.5, or the total? Okay, so that's a little different. The others, we just added the first and second equal to total. This time I gave you the total. Can I just call both of the others X? No, because I didn't say we put in the same amount of each. All right, so let's make one of them X. So if you put in 6 pounds of the 30, how much of the 3.5 would you need? 2, because we have to have 8 pounds at the end, right? If I put in 1 pound of the 30, how many do I need of the other? 7. put in 2 of the first, we need 6 of the other. How are we getting these numbers?
It's 8 minus whatever you said.
Yeah.
Yeah, 8 minus 6,
Your total minus the amount you already used. Quick check on all the others. We added the amount of the first plus the amount of the second to get the total. If I take x plus 8 minus x, do I get 8? Yeah. Okay, now it's just like all the others, so we multiply. So we get a 0.3x, 0.035 times 8 minus x, and 8 times 0.07. Good. And then how do we write our equation from this?
0.3x plus 0.035 parentheses 8 minus x is equal to 0.56.
So if we distribute combine my terms. Okay, does this one work out nicely? No. So you get like 1.0566 and it just keeps going on. Let's just put it in a fraction so we can give an exact answer.
56
So the question was, how much of the heavy cream was my 30% and that was my x. So this does answer my question. There should be 56 53rds or the 1 point whatever pounds of heavy cream. Any questions? We're going to stop here today. So the handout from yesterday we did 1 through 4. I want you to do 5 through 7 for Monday.